Okay, all right. So today we are going to start with the routing concept here. Okay, so we'll discuss first what is router. Okay, why we require router. Okay, where exactly we are going to use the router in the network. What is the use of that router? Then its components, its function. Then how we can able to be access the router. How many different methods available. After that one, the basic configuration of the router. That one. Okay, any idea what is router? Connects to different networks. Okay, any other answers? Okay, router is a specialized networking device connect to two or more network running software that allow the router to move data from one network to another network. Okay, router functions in an internet protocol based on the network operate at the network layer of the OSI model layer 3, that one. The primary function of the router is to connect the network together and keep the certain kind of the broadcast traffic under control. What exactly router? See here. See, this is my router A in this diagram, and router B I'm having here this one. Consider this is the headquarter and this is the branch office. I want to connect from the headquarter to branch office. See, in the headquarter we use the different IP address. That's a different network. For example, here you can see this 192.168 3.0 network. See, network is 3.0 network I'm using here. Then in the branch office, we are using a different network, 192.168 1.0 network. By default, it's possible to communicate within the same network. If the two different networks are there, then we require the routing here. So by default, it's not possible to. Then now I am connecting from the headquarter. Headquarter, it's in Bangalore. The branch office in Chennai, example. So in a Bangalore, we have one router, Chennai, we have router, and we have connected from Bangalore to Chennai. And this is the WAN connection, wide area network connection here. And to connect from this router A to router B, again, we have a different IP address. See, here within the office, 3.0 network. Here within the office, 1.0 network. I'm talking about last two octets here. Okay. Next 2.0 network. Now to communicate from here to here, then we require the router. Without router, it's not possible to communicate. Even you take within the organization, you have two different network IP addresses. For an example, so I'm using two different network IP addresses. One I'm using 192.168.168.10.0 network. Another network I'm having 192.168.20.0 network. For example, 10.0 network we are using for the marketing, and 20.0 network we are using for the sales here. Now I want to communicate from the marketing to the sales here. By default, it's not possible because this is the different network and this is the different network. Now what you can do, this one, you can use one router here. Okay. And this network you can connect, and this network also you can be connect. Now via this router, we can communicate from one network to another network. This is within the network here. Then from one office to another office or one location to another location, if you want to communicate, again, we require the router here. Okay, that is what the router also a special computer. Okay, which is designed to communicate between the two different networks. Next, it works in the layer 3 of the OSI model. If you remember in the OSI layer, okay, so which is the layer 3 network layer. So now the router operates under the network layer here in this one. Okay, and these are the different vendors who exist in the market who manufacture the router. See, Cisco, Linksys, Juniper, Netgear, Nortel, Redback, Lucent, 3Com, HP, D-Link, Belkin. These are the different vendors who exist in the market who manufacture the router here, this one. But in this class, we are going to be concentrate on only on the Cisco devices, this one, not on the other devices, this one. So this is the router, and this router also acts as a gateway. The router is also act as a gateway. Gateway means what? I'll come back on the next slide, that one. What exactly that gateway? Okay, so here we have few things. See, the function of a router, restrict broadcast to the LAN. What exactly this restrict broadcast to the LAN? Generally, what happen when you have a LAN network? Say example, I'm using one switch. Whenever if I write like this, you have to understand switch. There are multiple computers I have connected to this switch. if any PC sending the broadcast traffic, broadcast means what? Sending to everyone. This goes here, here, here. Okay. And now I'm having another switch here. Another switch. So there is another department is connected here. Suppose if there is a connection from here to here, direct connection from this switch to this switch. Now already this PC is sending some broadcast traffic, right? Now this traffic floods to the other switch also here. This is what broadcast. See, there is a unnecessary traffic is flowing in the network. If unnecessary traffic is flowing in the network, what happens? There is a huge traffic in the network. When there is a huge traffic, slow communication happens this one. So what we can do here in this scenario now, okay? Now I'm using a router here. Okay. After using this router, so see, I'm using router. This I have connected to the router, and this switch also I have connected to the router. Now there is no direct connection from this switch to this switch. Even these are the two different networks. If the broadcast traffic is coming, now that broadcast traffic goes to the router also here. But router doesn't support the broadcast traffic. Router supports only two types of communication. One is the unicast and another one is the multicast. Router supports only two communication, unicast and multicast. Unicast means one-to-one, multicast means one-to-many. But this is the broadcast traffic. If any broadcast traffic router receives, it's going to terminate there itself. It's not going to process that one. So that is what restrict broadcast to the LAN. When you have multiple departments in a company, every department having a different network. So all that networks will be connecting to the router to restrict the broadcast. One thing. Next, it acts as a gateway. So you are already aware, gateway means what? For an example, so this is the marketing department. Okay, marketing department. Now this router is connected to ISP. ISP. Now this PC has to be go to the ISP here. So how it can be go? Via this router it can go, right? So the traffic can hit to the router. From the router it can be connect to the ISP here. Now this router is in a gateway. Why? Because see, this is my LAN network. LAN network, local area network. And this is ISP. When it is connecting, it's a WAN network, wide area network. Now this router is connecting to the two different networks. It's connecting to LAN also, WAN also here, this one. Whenever from within the organization, if I want to go outside, via this router I have to go outside, or external traffic wants to become inside, via this router it has to become here. For an example, for your home, there is a gate. Okay, through that gate you can go outside, through that gate you can come inside. Similarly, in the networking, any traffic wants to be go outside, via this router it has to be go outside, via this router it has to be come inside. So that's the reason it acts as a gateway. Router is the gateway. Why we call it as a gateway? Because it's an edge device. Edge device means we can be, okay, any traffic wants to be go outside or any traffic wants to become inside, via this router or the gateway it has to become. So that's the reason we call it this as a gateway. Now even in the home connection, home internet connection, what happened? You have the one wireless router. Through that router only the traffic goes to the reaches to the provider here. So that is the gateway now. Okay, for your home connection. So that's what. Now perform protocol translation. Protocol translation means so multiple different protocols we can be enabled to communicate from one network to another network. Okay, and move data between the networks. Yes, whatever. Not only it's a building a path. For example, if you want to reach from one place to another place, source to destination path is very important. So it provides the path. Along with this one, after selecting the path, whatever the traffic you have, means information or data you have, this one, it's going to carry that information. So that is what the move route data between. Learn and advertise loop free paths. So we'll discuss what exactly loop free paths and best path, how it will be selecting. This is the concept of routing. Okay, so in the routing, what happens is it will be selecting the best path. Okay, how it will be selecting the best path depend on what protocol you have implemented. Every protocol having its own metric. to select the best path. After selecting the best path, it will be sending the net traffic. Whatever the traffic you have, it is going to be carry that one. So that's the function of router. So for router, we use to connect between the two different network. So, and the router is the WAN device. WAN device means if you want to connect WAN, for example, from your company to internet, you want to connect, router we require. Without router, it's not possible to connect to the ISP also. Or two branches you want to connect from headquarter to branch office, or branch office 1 to branch office 2, then also we require the router here. In the WAN, if you want to communicate, then the gateway we require. Without the gateway, it's not possible to communicate. Got it? So this is the picture you can see. This is how it looks, router. Again, depend on the model here. Again, series, we can say, router model, router series, we have this one. So these are the Cisco switches here. This is how it looks. Got it? Guys, are you following online?
Yes, sir.
Next, the components or parts of router, we have this one. So here you can see major internal components, means within the router, what major components we get: CPU, RAM, NVRAM, flash, ROM, console, interfaces. We have this one, CPU, central processing unit. Okay, so this is the actually brain of the computer. Everything, whatever the instructions you are giving as a user, as an administrator, to process that one, CPU is going to be used that one. Again, the different components we required here in this one. So let's see what exactly the different types of memory we have here in this one. ROM we have. ROM stand for read-only memory. It stores the bootstrap or startup program, operating system software, and post power on self test. That is a diagnostic program, that one. So, okay. Inside the router, we have one component called ROM, read-only memory, that one. So what exactly it stores? It stores the bootstrap program. Okay. Then also it stores the operating system. Post here, this one, power on self-test. Have you seen the computer, the desktop? Whenever if you turn on the computer, okay, not the laptop, I'm talking about the desktop. Whenever if you turn on here, if you, what happens? The boot up happens. Okay, boot up comes. Every electronic device, there will be a boot up process. Okay, once you turn on any electronic device, it happens boot up. Okay, in that boot up process, what happened here? This one, there is one diagnostic tool. Okay, that's called post. Post is the diagnostic tool. What exactly? It's a small program actually. The post, power on self test, means once you power on, self test of what? The device. Means to boot the device, we require some components, mandatory components we require. Example, for example, you required CPU. Guys, can you go into mute? Nadim Pasha. Okay, so what happened here? There are components we require. For an example, you have not connected your keyboard, or you have not connected your mouse. Still the boot up happens, and keyboard and mouse is not mandatory to boot your system. But if there is no RAM in your motherboard, is it possible to boot? It's not possible. If there is no CPU, is it possible to boot? There is no hard disk, is it possible to boot? That is what in the post, what happened this one, it's going to be check it out, what is the mandatory devices to boot my system. It's going to check it out, all the devices are connected and it's working or not. So if you remember that one, so if you turn on the machine, what happened? Your keyboard will blink, your mouse will be blink. That means it's checking all the component. At the same time, it gives one beep sound. Teet. That means single beep you are getting, that one. Single beep when it is giving, that means all the devices are connected and it's functioning as it is designed. Okay. Now it can be boot, that one. There is no issue, that one. Like similarly, router also, if you want to boot, So we require some components here. Okay, it's going to be check it out. All the components are connected and it's working as it is designed, that one. To check that, we use one diagnostic tool called POST, Power on Self-Test. That is a small program. That program is going to be stored under the ROM. Where exactly it stores in the router means on the ROM it's going to be stored. For example, if you turn on your computer, continuous beep you will be getting. Teet. That means your RAM is not working. Either RAM is not connected or RAM is not working. That's how the post beep sound we have. 2 beeps, 3 beep, 4 beep, continuous beep. This is how we have this one. Through that, you can understand that one, what is an issue on that one. So which is providing by the post. Here also we have a post. Once you turn on the router, okay, post is going to check it out. All the components are connected and it's working. Okay. Now this post is the small diagnostic program. Where exactly it's going to store in the router means on the ROM, read only memory it's going to be stored, that one. Got it? What is ROM? Okay. And startup configuration means to start up your router, some startup configuration we require, that also stores under the ROM here. Next is the flash memory. It's like a hard disk, right? Where exactly your data stores in your computer? Hard disk. In the router, where exactly the data stores? In the flash. Okay. And also operating system you are installing in your this one hard disk. Here also operating system of the router stores under the flash. For that operating system we call IOS, Inter-Network Operating System. Okay, that is a flash memory. Next, RAM, random access memory here, this one. Anything after, see, instruction goes to the CPU. After the CPU, that goes to the RAM. The RAM is going to store all the information temporarily, then it gives the output. Now, for example, I'm running some application here. So I have given some instruction, which application to be open. Okay, now it has gone to the CPU. Now CPU is giving that information to the RAM. Now RAM is storing temporarily and it's giving the output to me here in the laptop. Similarly, router also, whatever you are doing, when you are accessing, whatever you are doing, that one, the instruction, it goes to the CPU to process. After the completion of the process, it gives to the RAM, and in the RAM, it's going to store temporarily and it gives the output. Okay. So that's what RAM here, this one. Okay. What happened? Running configuration, we can say that one. Running means whatever you just turn on, whatever you are doing. Now, whatever I have open here, if you can you see this one? See how many applications I have open? So all these applications, now it's stored under the RAM. If I restart my machine, whatever application I have open, it will be gone. Why? Because it's stored temporarily, that one. So that's how here also running configuration stores under the RAM. Means whenever you are accessing the router and doing some configuration, that stores under the RAM here. Next, NVRAM, non-volatile RAM. Okay. So here the router startup configuration means, for example, router you are accessing, you are doing some configuration. After that, you have to save that configuration. You have to. Once you save that configuration, that saved configuration goes to the RAM, NVRAM, sorry. That is called startup. Means whenever if you turn on the router, which already the configuration which you have said earlier, it's going to load that configuration. From where it's going to be load? From the NVRAM, it's going to be load that one. So that's how we have the different types of memory: RAM, NVRAM, ROM, flash memory, and everything. This one. Got it? So that's how the boot up process. What happens once you turn on the router? Post happens. Okay, post is going to be check it out. All the network devices, all the components are connected and it's working. After that, what happened? This one, it goes to the configuration registry files. Okay, why we use this configuration registry files? To find out where exactly your operating system IOS is stored, because IOS we can be stored in 3 different places. One on the flash we can be stored, that's locally, or TFTP server we can be stored, and ROM we can be stored here, this one. So always once you turn on the router, first it looks for the flash memory inside the router. So okay, always we store the IOS in the flash only. Anywhere you go, even in the production you go, we store the IOS where? Means IOS means operating system of the router, Inter-Network Operating System. Flash. Okay. Once it finds the IOS, it loads the IOS here. Suppose it's unable to find the iOS in the flash. Then it's tried to connect to the TFTP. That's an external server. Okay. It has to be configured in the router. It has to be configured. Once one means by default, there is no configuration. You have to configure whenever if you turn on the router has to go to TFTP server and it has to load the iOS from the TFTP server. That's how you have to be configured. Suppose you have not configured any TFTP, separate server, that one, that's not in router. Okay, that's not in router. That is a separate server, TFTP server. Okay. Then see, I don't have the iOS in the flash. I don't have TFTP server configuration also. Finally, router loads the iOS from the ROM. But whatever the iOS we have this one, so with that iOS, it's not possible to configure anything. Okay. It goes to the Roman mode. Means whenever you turn on the router, it displays like this. Okay. Roman. It displays like this one. That means if it is displaying like this, Roman greater than value, if you can see that one, then you can understand there is no iOS on the router. Now it's loading from the ROM, that one. Okay. Then it goes to the, once it finds the, for example, I have a iOS in the flash memory. It loads, then it goes to the NVRAM. In the NVRAM, it's going to check it out. There is any saved configuration. If the saved configuration is there, it loads that one. If there is no saved configuration, then it goes to the setup mode. Setup mode means what happened? So it will asking you to be configure the router, that one. That's how the boot up process happen. Got it? This is the boot up process of router. Clear? Got it? Any doubts? Any questions? Yes, that has to be configured, that one. Example, for an example, this is my router, okay, which is connected to the switch. Here there is one external server. This is the TFTP server. Okay, you have to make it some application, TFTP application has to be installed to make it. Once you turn on the router, here you have already configured that one. Okay, go to this server and load the iOS, because iOS we have stored here in this one. Now it's going to load the iOS here temporarily, that one. Which one? No, it's not possible to configure, which you have configured here. Okay, then connectivity should be there. Configuration should be done here in this one. Yeah, connectivity should be there, right? To reach till the TFTP. Either you go with, then obviously the cable has to connect and everything. Okay, but generally we will not do all these things. Even in the production network, always we store the iOS in the flash only. But you have an option if you want to, you don't want to store the iOS local router, you want to store it in some other place, you can do it, that one. But nobody will do that one. Okay, next, network interfaces. We have this one. Okay, that's in a very important network interfaces. There are different types of port we have. Ethernet, fast Ethernet, gigabit, serial, console, auxiliary, loopback interface. We have this one. So what exactly these ports and why we require this port? For an example, I'm having a router. This is the router I'm using here. And this is my LAN network. LAN means local area network within the office, that one. This is the router. Then this router here in the LAN network, you can connect any other device also. You can connect any other device. Any other device means you can connect router to router, or you can connect firewall, router to firewall, or you can connect switch, or you can connect IPS. Means locally within the LAN, any other device wants to connect to the router. Router also, another router also you can connect. Any other device, any other network device. You are not going to connect PC directly to that one. Any other network device like router or switch, firewall, IPS. This is how any network device you want to connect. Then we use these three ports. Ethernet, fast Ethernet, gigabit Ethernet. The latest is gigabit. This two we are not using now, Ethernet and fast Ethernet. Okay. Locally, router wants to connect to the any other device in the LAN network. Always we use the gigabit Ethernet port. Okay. If there is a Ethernet and fast Ethernet, that also you can use it. But now the latest routers, whatever you take that one, every router we have the gigabit Ethernet port, not the fast Ethernet and Ethernet port. Now, what is the difference between this Ethernet, fast Ethernet, gigabit Ethernet? Means speed. Ethernet supports only 10 Mbps speed. Fast Ethernet supports 100 Mbps speed. This support 1 Gbps to 10 Gbps. That is the difference. Ethernet, fast Ethernet, and gigabit Ethernet. Okay. So only the speed. This port we use for what? This fast Ethernet, gigabit Ethernet, it is used to connect what? You can connect any device on LAN network, locally on the local network to connect any other device. Okay, we use always Ethernet port. These are the Ethernet, gigabit Ethernet ports we are using that one. Got it? Now, ISP you have. ISP means what? Internet Service Provider. This is your office router. Okay. From this router to ISP you want to connect. Now this is called WAN, Wide Area Network. And also we call it this as a public network, right? This is internal LAN network. It's a private network. That's my private network. The WAN is public network. Okay. Now to connect from router to ISP, or I have the another branch office. I have the another branch office. In the branch office also, I'm having a router. Now I want to connect, consider this is the headquarter. From the headquarter to branch office, I want to connect, or from the office to ISP, I want to connect. This is comes into the WAN or public network, this one. To connect this, we use serial interface. We use what? Serial interface. Serial interface. Router to internet, router to branch office you want to connect, then always we use what? Serial interface. Serial interface we use only for the WAN to connect router to router. Here, router to switch, router to firewall, we are not connecting in the serial. Okay, router to router only. You can connect Ethernet port. LAN, any device you connect. That's what I have given here, router to router. See, one more thing. Whenever if I write like this, you have to understand it's a router. Okay, I'll explain you. Whenever if I write like this, understand that's a router. Or whenever if I write like this, you have to understand it's a WAN connection. Whenever if I write like simple, like this or like this, you have to understand switch. Okay, that represent of diagrams. Got it? That's a serial port we are using this one. Okay. Next, you have a router. It's a brand new router. Brand new router, you don't have any configuration. First time you want to access the router. How you can access? From your laptop or computer you can access. For example, this is my laptop. From this laptop, I want to access the router. So then I can take one cable and connect to this router. This is called console cable. And here in this router, we get one console port. We get what? Console port. In this console port, to access the router directly, physically, the console port, we use this one. Auxiliary port also for same thing. Either you can use console or auxiliary, but generally we will not use the auxiliary port. Always we use the console port to access the router. Another loopback interface, we have this one. We'll discuss later that loopback interface. Loopback interface also, it's like a logical interface. See, this fast Ethernet, Ethernet, gigabit is the physical ports. Physical means what? Where physically means that modules are exist that you can be see and you can feel that and touch that one. Loopback is the logical. That's not as physical. You can be create. And why we require the loopback interface, which scenario we are going to use the loopback interface, that we'll discuss later. If I explain now, you will not understand. It will get bounced. So later will be discussed when we do the different practicals. In that scenario, I'll explain you that one, how we use that loopback interface, that one. Got it? So these are the different ports we have. Ethernet, fast Ethernet, gigabit Ethernet. These are the port we use to connect in the LAN. Any device to router you want, router to router or any device. Serial interface we use to connect on the WAN, router to router over the WAN, like internet it's connecting or the branch office it's connecting, then we use the one. Console port we use to access the router physically, direct access that one. Because the brand new router, so you don't have any configuration. First time always you have to go access with the console. Then after you can do some base configuration. After doing the base configuration, then you can access remotely. Now, for example, I'm sitting here in Bangalore. My data center, it's in US. The router in there. I'm accessing that one. So console cable, I'm not connecting. Remotely, I'm accessing. To access the remotely, some base configuration has to be done. Once it's done, you can be able to be access that one. So what is that base configuration? Everything I'll explain you later that one. So we'll do the basic configuration after accessing the router. In that, we'll see that one. Got it? The ports are very important. Example here, some router we have. You can see that one. Two different models I'm using here. So this is the 1841. That's a model, router model. Cisco 1841. Can you see this one? So here you can see that one. Here, this is the product serial number. Every device, hardware device, you'll get some serial number. That's a unique number. Even you take your mobile phone also, you get some serial number, that one. So that's the serial number here we have. Then this is the power input. Okay, it has to be power it here. And this is the power on and off button here, this one. This we have this one. Then here you can see this one. See, these are the ports. This is the console port. Always console port, it will be in a blue color, something here. And it will be written there. It's a console. Next to that, actually, always it comes in a black color. Okay. And these are the fast Ethernet. Can you see this one? FE0/0, yellow. Ethernet, fast Ethernet, gigabit, it comes in yellow color. Okay. It display. If it is a FE, fast Ethernet means FE, gigabit Ethernet means GE. GE means gigabit Ethernet. E. Now you can't find that E and FE. That's 1841. That's an old router. Now we are not using this 1841 router. So we have 4000 series router now. Latest model is 4000 series router. Okay. Next, this is the USB port. And this is, can you see this one? This is the flash memory. You know, like memory chip card you'll be getting, right? Same, the SD here, this one. This is the flash where you can insert here and you can remove. And this is your serial interface. Again, serial, we have two types of serial. This is the DB9, old connection. Can you see this one? Which looks like a VGA card, where monitor you are connecting to your CPU, right? It looks like that, but it's a serial interface. Okay. So coming to another model we have here in this one, I think this is the 2800 series. See, same thing, power card, power on and off button. These are two different routers. Yeah, if it is supporting, you can do it that one. No, again, we have a different thing. That one we'll discuss later. That one, because IOS, how Cisco designed the IOS, how they have developed means, for example, you're taking the Windows 10 operating system or Windows 7 operating system. That's a generic operating system. You take any vendor hardware, you can run it on that one. You take Dell, you can take Lenovo, any laptop, desktop you take, you can install the operating system. Okay, that's what generic that one. iOS is not like that. Suppose Cisco developed the iOS for 1840, 1800 series means you have to install in the same router. So if there is a 2800 series router, it's not possible to install. Every different router, they develop different operating system. If it is the same module same. Another 1841 you take, you remove this flash and insert, it will be work. Yes, yes. So that's how you have to understand. See here again, power on off model, auxiliary, say always black here, always. Console blue, Ethernet port, fast Ethernet, gigabit Ethernet. And this is the serial port DB9, and this is the smart serial. Now the latest we have like this. See, in one module, this is the module, means by default, you will not get all this thing. You have to purchase the separate module and you have to insert on the router. Smart serial, see, one module, one interface, one module, two interface we have. Can you see this one? Two interface we get it. That's called smart serial we call it. Okay, this will discuss in the next class, the basic router configuration. So any questions, any doubts before we wind up?